Okay. Hello everyone once again. Just before we have completed semiconductor part 1, looking at the preparation of CET, JWM NEET. Now we are moving towards part 2, right? Now in this part 2, what we have to understand is something about the application of diode or PN junction. The first and foremost application is light emitting diode, that is LED, and that is discovered by Nick Pollack in 1962. He is the one because of whom we are enjoying LEDs nowadays. So, constructional diagram for this is a metallic contact. There is one P and N type material, right? Two metallic contacts are there. Means whatever we have seen from the LEDs, two terminal, right? So these are two metallic contact where we will connect the battery, right? And it will conduct the light whenever electron passes from negative to positive. From that, light is emitted continuously. So this is the symbolic representation of LED. Prior to this, we have seen only this much part. Now, if you will add arrows on that, which are coming out, that is nothing but light emitting diode. If the arrows are coming towards that diode, that became photodiode. That became photodiode. Now we will see the working. N-type semiconductor is used as a substrate or a base. N-type is used as a substrate or a base. A thin layer of P-type semiconductor is formed by diffusion process. So एक छोटा सा layer उन्होंने ऊपर की तरफ बनाया with the process of diffusion. Gold is deposited on the bottom of N-type substrate. At the bottom, what is deposited? Gold. This layer is used to make contact with the material, and in addition, it reflects light. It reflects light. So, exposed top surface of N-type semiconductor is covered with SiO2, which acts as an insulator. So, whatever we are observing over here, that is of SiO2. Metallic contact are provided along the edge of the P-type top layer. Metallic contacts are given at the P-type top layers. Means whatever may be the leads or terminals we are getting from where we will give the input voltage, that is here termed as metallic contact. An above assembly is enclosed inside a solid transparent dome-shaped plastic material. Dome-shaped plastic material. Lead wires or connecting wires are brought out from the bottom of plastic dome. Now working, the one which we discussed now was construction. Now we are talking about working. A series resistance RS is always connected with LED. So how it is? There must be always a resistor with LED so that current flowing through the LED does not exceed its maximum permitted value. So इसके शुरुआत में हमें हमेशा क्या चाहिए? Resistance in series, and we can connect a battery to it. Right? It means even if the voltage increases, it will not blow off. Q, because LED cannot sustain for more than 1.5 volt, right? It can only survive between 0.3 to 1.5. When the PN junction is forward biased, the diffusion of majority charge carriers takes place across the junction. When the PN junction is forward biased, the diffusion of majority charge carrier takes place across the junction. सर ये नहीं समझा हमें. क्या कहा है? When the PN junction is in forward bias, तो सर ने आपको फर्स्ट पार्ट में क्या समझाया था? When it will be in forward bias, when positive is connected, right? Only symbol will change arrows, otherwise diagram remains same. So here positive, negative, positive, negative. When PN junction is forward biased, the diffusion of majority carrier takes place across the junction. Diffusion of majority carriers means this is what middle point is junction, and as we have discussed earlier, when two charges are opposite, they will attract each other. So majority carrier, in this case majority carriers are negative charges, and they will get diffused at this terminal, right? So majority charge carriers takes place across the junction. I hope now you understand. So certainly we have to break the barrier again, and after breaking that barrier, conduction will take place and light will come out. So if I'll ask you a question, have you seen photons so far? So answer must be yes. We all have seen the photons everywhere. Wherever there is LED is installed, the light which is coming out of that LED is nothing but photons. The electrons move from N region to the P region through the junction, and holes move from P region to N region through the junction. Right?
Yes.
Already we have discussed that just now, and in the previous part also we have discussed everything about PN junction. So during recombination of electrons, the holes, sum of the energy difference is given out in the form of heat and light, and that is nothing but photons. So these are some applications, street lights or signals, right? These are some applications of LED, right? LED lights, many of them are using LEDs, right? So these are some basic applications of LEDs. So many of the applications are there which are using LEDs. Now, next application of LED is 7-segment display. Next part is 7-segment display. So what this 7 segment belongs to? It means when 7 LEDs are connected together in the form of shape of 8, right? That is called as 7 segments. So that can display 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And it has the basic standard consideration is the upper one is termed as A, B, C, D, E, F, G, and somewhere it is mentioned as H, that is dot point. Deep is dot point, which you are observing after every visit. Advantages of LED: LEDs are cheap, LEDs require low operating voltage and low power, they have longer life and lightweight, they have high operating speed, the switching time is nanosecond, different switching time is nanosecond, different spectral color output are possible. These are the advantages of LEDs. So how we will get different colors? So for that, these are few combinations by which we will get different type of colors. So for green, gallium phosphide is used. For yellow, indium phosphide is used. Gallium arsenide phosphide is for red, and gallium arsenide is for infrared. Right? Now, as we have discussed in the previous episode that we have to study something about VI characteristics. So this VI characteristics is for forward bias. Always keep this in mind basic PN junction always works in forward bias. LED also always works in forward bias. Further, in the next few parts, we will come to know about photodiode, solar cell, and we will discuss something about Zener diode. At that time, we will discuss in which bias conditions they are working. But now, you have to keep in mind, basic PN junction works in forward bias, and LED works in forward bias. So therefore, we are discussing about forward bias VI characteristics. When LED is in forward bias, anode voltage is increased, that is positive voltage is increased in small steps. Current doesn't flow until the barrier potential is reached. क्यों? क्योंकि barrier potential break करोगे तभी conduction होगा, right? So आपको ये जो ग्राफ दिख रहा है, here we have voltage on X and current on Y. So जैसे ही ये voltage start होता फ्लो ना, right? वो तब तक इंक्रीज नहीं होता जब तक हम लोग बैरियर पोटेंशियल ब्रेक ना करें. तो जैसे ही बैरियर पोटेंशियल ब्रेक कर दिया, करंट स्टार्ट फ्लोइंग, हमें इंटरेस्टेड करंट को फ्लो करने में, राइट? सो करंट विल स्टार्ट फ्लोइंग व्हेन बैरियर पोटेंशियल विल ब्रेक, राइट? whenever the barrier potential got break or broken, we will start getting current. The barrier potential depends on the type of semiconductors used. For gallium arsenide phosphide LED is about 1.5 volt. So as I said earlier, LEDs generally work between 0.3 to 1.5. So this is the voltage of 0.3 or 0.5 based on silicon or germanium type of semiconductors or PN junction or LEDs, right? So it means 0.3 पर या 0.5 वोल्ट पर वो ब्रेक करेगा पोटेंशियल बैरियर को या फिर डिप्लीशन लेयर, और उसके बाद कंडक्शन होगा. LED current increases with the voltage intensity or light emitted increases. We never apply large reverse voltage. So greater than 5 volt LED को अप्लाई नहीं करते. सर अभी तो आपने बोला था 1.5 पे वर्क करता है. So 5 वोल्ट क्यों दे रहे हैं? बिकॉज उसके साथ सीरीज में रजिस्टर है, इसलिए 5 वोल्ट को डैमेज नहीं करेगा. अगर रेजिस्टेंस नहीं है और 5 वोल्ट दिए तो शायद वो डैमेज कर सकता है. Thus, the VI characteristics of LED is quite same as the ordinary PN junction. Just now I said basic PN junction, ordinary PN junction diode works in forward bias. Similarly, LED works in forward bias, and that is the reason the characteristics is same as that of PN junction, right? Now, moving ahead, Zener diode was discovered by Clarence Zener, and with his honor, we are calling the diode is Zener diode. So this is what the picture of diode, Zener diode, which is available in market. Now, this is the symbol of Zener diode, and very important highlighting part. It can operate in reverse bias because of its high doping level. उसका doping level बहुत ज़्यादा है, and then therefore it works only in reverse bias. So अब तक हम सब लोग forward bias की बात कर रहे थे, तो this is the one who is working in reverse. So if I need to elaborate something about Zener voltage, so what is Zener voltage? Breakdown voltage is that value of the voltage at which the reverse bias junction breaks down and reverse current suddenly increases to the large value. अभी हमें forward current की बात नहीं करनी है. क्यों? Because it does not work in forward bias. We have to talk about reverse current because it works in reverse bias. So इससे benefit क्या होगा? ये कुछ एक special case निकला Zener diode. So there must be some special application of Zener diode. So we will see that special application. But before that, let us conclude the working of it. What is the working? Pay attention here. doping level is inversely proportional to width of depletion layer. So जितना ज़्यादा doping उतना depletion layer कम, उसका width कम, और जितना कम doping level उसका width ज़्यादा. If doping level increases, then conductivity increases. Then
conductivity increases.
क्यों? Because depletion layer कम है, तो conductivity fast होगा. As depletion layer provides resistance, so it decreases breakdown voltage, and that is directly proportional to the width of depletion layer. Zener diode characteristics. So far we were talking about forward bias. Now here the characteristics is in third quadrant. It means both X and Y are negative. Both X and Y are negative. So therefore the characteristics of Zener diode comes in reverse biased, so below I means minimum current. Below minimum current, Zener is not operated. Above I max it may get damaged. I max के ऊपर वो डैमेज होगा और I min के नीचे वो काम नहीं करेगा. It means it is active only for I min to I max. Breakdown voltage depends on the amount of doping and depletion region. Breakdown किसके ऊपर डिपेंड है? ये जो breakdown हो रहा है ना, डिप्लीशन लेयर को ब्रेक करना है, वो किसके ऊपर डिपेंड है? टोटली डिपेंड्स ऑन अमाउंट ऑफ डोपिंग एंड डिप्लीशन रीजन. सो Zener diode एज अ वोल्टेज रेगुलेटर, तो मैंने जैसे कहा उसका एक स्पेशल एप्लीकेशन क्या है? Zener diode एज अ वोल्टेज रेगुलेटर. द सर्किट व्हिच मेंटेन कांस्टेंट आउटपुट वोल्टेज इज नोन एज वोल्टेज रेगुलेटर. सर्किट व्हिच मेंटेन कांस्टेंट
आउटपुट वोल्टेज.
कांस्टेंट आउटपुट वोल्टेज. सर ये क्यों काम आएगा? We are using very expensive laptop, very expensive television, very expensive fridge, washing machine, AC, and number of electronic applications we are using, which are very expensive. And to all we are giving a same input current of 1 ampere and voltage of 220 or 230 volt from our household single phase. But there might be fluctuation. Right? We never know. So because of that fluctuation, that devices may get damaged. So to prevent that devices, we have to use Zener diode. So that simple small Zener diode plays very important role to secure our electronic devices from damage. So what will be the diagram? Yes, this is the diagram of Zener diode working as a voltage regulator. Children. In examination, they always ask, explain Zener diode acts as voltage regulator. For that, this diagram is most important. You have to draw this diagram only. It has input voltage, output voltage, resistance in series, Zener diode, and load resistance. Now we'll see the working. Now here, whatever input current we are giving, please pay attention very carefully how Zener diode works. What we have mentioned I, the input current is divided into two parts, IZ and IL. Therefore we have written I is equal to IZ plus IL. Right? I is going to IZ as well as IL. Now, input voltage, we are talking about input voltage. VI is nothing but voltage across resistance and voltage across Zener diode. Sir, how there is voltage across resistance? Because based on Ohm's law, what we have studied, V is equal to
I.
What is the statement of Ohm's law? In a current carrying conductor, potential difference at the end of the conductor is directly proportional to the electric current flowing through it, keeping its resistance or keeping its physical state constant. So based on that formula is V is equal to IR. It means wherever there is a product of current and resistance, there must be drop of voltage, right? So here we are passing current through the resistor, right? We are passing current through the resistor. It means it has voltage drop. It has voltage drop. So from where that voltage drop is? From input voltage. वो घर से तो वोल्टेज लाएगा नहीं, जो भी आप इनपुट दे रहे हो उसी में से वोल्टेज ड्रॉप होगा ना. सो इनपुट कौन सा है? इनपुट वोल्टेज. तो उसमें से कुछ वोल्टेज कहाँ पर चला गया? रेजिस्टेंस में. अब बचा हुआ कहाँ पे जाएगा? ZR में. So VI is nothing but VS plus VZ. यहाँ तक क्लियर है? डेरिवेशन समझना बहुत इंपॉर्टेंट है 5 लाइन का ही, और उसे समझना बहुत इंपॉर्टेंट है ना. उसी VS को अब मैंने क्या लिखा? ओम्स लॉ के जरिए IRS. ये भी क्लियर है सबको? बट I क्या है? IZ plus IS, वो भी मैंने यहाँ पर लिख दिया, राइट? और VZ को ही मैं V0 भी बोल सकता हूँ, पैरेलल वोल्टेज. VZ को मैं क्या बोल सकता हूँ? V0. Since V0 is equal to VZ. Sir, why we are reaching to V0? Because that is what we have to show, that it maintains the output voltage, right? So after understanding that 5 lines, VI increases because of line voltage variation. Means line voltage variation मतलब input voltage variation. उसी के base VI increases because of line voltage variation. I increases
but V remains constant.
ठीक है, ये यहाँ तक हुआ था. और हमने क्या लिखा? VI increases because of line voltage variations. IZ increases but V0 remains constant. IZ बढ़ेगा but V0 constant रहेगा. The excess current is dropped across RS and V0 remains constant. कैसे constant होगा? क्योंकि excess जो भी current है वो RS में चला गया, बचा हुआ VZ को constant करेगा. If IL increases, then IZ decreases. IL अगर बढ़ गया तो IZ कम होगा. क्यों? क्योंकि जो इनपुट करंट है उसी में से इसको एडजस्ट करना है. उससे ज्यादा तो होगा नहीं ना. जितना इनपुट है उसी का सर्किट में फ्लो होगा. तो अगर एक पैरामीटर उसका बढ़ गया तो दूसरे कम होगा, राइट? So if IL increases, then IZ decreases, but V0 remains constant. So in both the cases, the line voltage variations and load current variations, the output voltage remains constant. मतलब कुछ भी चेंज होने दो, लाइन वोल्टेज चेंज होने दो या लोड करंट चेंज होने दो, इनपुट चेंज होने दो या आउटपुट चेंज होने दो, in both the cases output voltage remains constant, and thus it acts as voltage regulator. अब इसका यूजेस क्या है देखो. It is used as voltage regulator. It is used as reference voltage for comparison purpose. It is used for the protection of current meters against damage due to excess meters. तो यहाँ पर सिर्फ current meter का है, but all electronic devices can be prevented from getting damaged because of fluctuation in the current. We can use Zener. So here ends the part number 2 theory part. Now we have to understand CET based questions. So just wait, I open that CET questions for you, and you all have to answer that questions based on this particular knowledge. Okay, so we will start. कौन बनेगा करोड़पति? So आप सभी का स्वागत है. कौन बनेगा करोड़पति में? Semiconductor. We have first question. In which one of the following device the reverse bias characteristics of PN junction diodes are used? And आपके कंप्यूटर के ऊपर है 4 ऑप्शंस. ऑप्शन नंबर ए एम्पलीफायर, ऑप्शन नंबर बी जेनर डायोड, ऑप्शन नंबर सी ऑसिलेटर, ऑप्शन नंबर डी लॉजिक है. बहुत सोच समझ कर आपको आंसर देना होगा, क्योंकि आप कुछ भी नहीं जीतोगे अगर आपने गलत आंसर दिया. Okay, jokes apart, what must be the answer?
Zener.
Zener. Okay. तो कंप्यूटर जी लॉक कर दीजिए बी जेनाडाइड। ओ ये सही जवाब। इसी के साथ बच्चों ने अपना खाता खोला। I have mentioned selected question out of the huge question bank, and that's why it is question number 56. Otherwise, you may get confused. You are asking, sir, question number one and showing some other. But anyways, focus on the second question. The VI characteristics of PN junction reverse biasing results in options: leakage current, current which cannot be neglected, no current flow, and large current. बहुत सोच समझकर आपको आंसर करना होगा। हम अगले पाड़ा पर पहुंच चुके हैं। आपने पहले क्वेश्चन का आंसर सही दिया था और इसी के साथ शुभम जी आंसर दे रहे हैं।
नो फ्लो ऑफ करंट।
नो फ्लो ऑफ करंट। क्या इसे लॉक किया जाए?
यस सर।
श्योर?
यस सर।
कंप्यूटर जी ऑप्शन सी नो फ्लो ऑफ करंट, इसे लॉक किया जाए। और इसी के साथ साथ शुभम इस खेल से आउट हो रहा है। उन्होंने आंसर दिया नो फ्लो ऑफ करंट। व्हाई? In VI characteristics of PN junction reverse biasing results in leakage current. VI characteristics of PN junction reverse में लीकेज होता है। नो फ्लो ऑफ करंट नहीं, फ्लो तो हो रहा है ना करंट। रिवर्स बायस हो या फॉरवर्ड बायस हो, it will try to flow some amount of current out from that. So there is leakage current. कोई बात नहीं, कोशिश करने वालों की हार नहीं होती, लहरों से डरकर मौका पार नहीं होती। Consider the following statement A and B and identify the correct answer. A. These are the statements which we have to consider, and based on that we have to answer. A Zener diode is always connected in reverse bias. B. The potential barrier of PN junction lies between 0.1 to 0.3 volt approximately. And आंसर देने से पहले इसे ठीक से पढ़िए। A and B are correct. A and B are wrong. A is correct but B is wrong. And A is wrong but B is correct. So Hitesh, option C, A is correct but B is wrong. So कंप्यूटर महाशय इसे लॉक कर दिया जाए ऑप्शन सी, और सही जवाब है ऑप्शन सी, that Zener diode is always connected in reverse and potential barrier of PN junction lies between 0.1 to 0.3 approximately. That is not, it is 1.5. Okay, अगला सवाल, Zener breakdown occurs only when? Very simple question it is, but before answering please pay attention on the options. It is lightly low, it is forward bias, the temperature is increased, and it is reverse bias. Yes, option D reverse bias. Okay, कंप्यूटर जी कृपा करके हमें आंसर बताएं, और ये आपका सही जवाब है ऑप्शन डी, इट इज रिवर्स बायस। वेरी गुड। Zener diode is operated in the, ध्यान से आंसर देना होगा आप सभी को। Zener diode is operated in, yes, C। आपका क्या कहना है?
ब्रेकडाउन रीजन।
ब्रेकडाउन रीजन और डिप्लीशन रीजन, इसमें कंफ्यूजन है। We'll see the answer, and the correct answer is breakdown region. Why? Because Zener always works in reverse breakdown, right? So whenever lecture is going on, please focus on that, and that is the reason why I am going live, because many of the times student found difficulties to recall that lesson again and again. So now the lecture is already recorded, so for those who are not able to answer correctly, I'll request them, please go and watch it again and try to give correct answers. Few questions are there. What is the Zener current in the following circuit? Now here you have some calculations. So very important to calculate and know the answer. You have already derived the equations, so you have all the formulas with you. Based on that, you have to answer. See, input voltage is 150 volt. Input voltage is 150 volt. Here the resistance is of 5 kilo ohm. Here the current which is getting inside RL is 5 milliampere and voltage is 50 volt across Zener, right? So what must be the answer? We will see the calculations. I is equal to Iz plus IL, and that I is nothing but V upon R based on Ohm's law. If we put the values 150 minus 50 upon 5 into 10 raised to minus 3 milliamperes, so that is 100 upon 5. So I is 20 and 20 is equal to Iz plus 5. 20 is our input, I plus Iz plus IL, right? IL is 5 milliampere and I is 20. So 20 will go on that side. 20 minus 5 is 15. So correct answer must be
15 milliampere.
15 milliampere. Now LED is, there are 4 options for you. What must be the answer?
Option A.
ऑप्शन ए फॉरवर्ड बायस पीएन जंक्शन डायोड. कंप्यूटर जी, और ये सही जवाब. अगला क्वेश्चन, दी ऑन ऑफ टाइम और स्विचिंग टाइम और ऑफ लाइट एमिटिंग डायोड इज ऑफ द ऑर्डर.
ऑप्शन बी.
ऑप्शन बी नैनो सेकेंड्स. लग रहा है हमारे बच्चे धीरे धीरे होशियार बनते जा रहे हैं. इट्स गुड दैट your answer is correct, and for you there is a small gift of 5 questions. You all have to solve these questions as an assignment. So note down the questions and try to solve it based on the prerequisite knowledge which we have discussed in the part 1 and part 2 of semiconductor. Now I know you people might be excited to know more about the semiconductor, so we are coming back with the part 3 very soon with very exciting questions of CET, JEE and NET. So stay tuned for semiconductor part 3. Meanwhile, I request you again, please revise part 1 and part 2 so that we will move ahead for part 3. Those who have missed any of the content, please look forward for that by clicking on the link, so that you can easily understand part 3 and further parts of semiconductor. Till then, thank you so much. Have a nice day.